Limits at infinity. We are going to look at essentially 4 versions of questions that use limits at infinity. A limit at infinity is the limit as x tends to infinity, or the limit as x tends to negative infinity of some function. We're going to show you a technique for doing rationals when the numerator and denominator have powers. So that's going to be things like 4x cubed plus x over 2x squared minus 4x, that kind of thing, right? Then we're going to look at rational functions that have square roots in them. So that might be like the square root of x squared plus 1 over 2x plus 1, things there, square root somewhere. And then we're going to look at rational functions where there are other functions involved. So it might be e to the x plus 1 over 2e to the x plus 2, something like that, perhaps. We're looking at a theorem called the squeeze theorem. And I forgot one more. Can't think of what to call them, so I'll call them the rest. So any question that doesn't follow it, kind of fall into that category, will be the rest. So let's start off with some properties that are just, we can assume are true. If you take a number over any positive power of x, right, 7 over x cubed, 7 over the square root of x, the limit as x tends to infinity of that is 0. And the limit as x tends to negative infinity of things that look like that are also 0. That's going to be very important for the first one in particular, and less so for the others. Now, if you go the other way around, you get infinities and you get minus infinities. Does that seem intuitive? The x cubed over 7 would be infinite as x goes infinite, and the x cubed over 7 would be negative infinity. Those guys are actually going to be useful in situations like number 5. So let's show you the technique for how to deal with limits at infinity of rational functions that contain powers. So suppose I was being asked to find the limit as x tends to infinity. Oops, there's my dog telling me there's a leaf, of 3x squared plus x cubed, and I'm deliberately mucking about with them a little bit. That, right? So basically, if you have a polynomial on the top and a polynomial on the bottom, you're going to solve the limit as x tends to infinity in the following way. The first thing you're going to do is find the largest power. X. Would you agree in this case it's x cubed on the top and it's also x cubed in the bottom? So the largest power of x is x cubed. Are you happy with that? Then what you do, you divide top, the bottom, by this power. So in this question, this fella, I'm going to divide the top and the bottom by x cubed. The reason we're allowed to do that is it's very, very closely related to multiplying by a special version of 1. I mean, essentially what I'm doing is multiplying by 1 over x cubed over 1 over x cubed, but it makes more sense to write it down as a division. So what I'm now going to do is see what we get. If you divide this by x cubed, you get 3 over x. If you divide this by x cubed, you get 1. If you divide this by x cubed, you get 2. You divide this by x cubed, you get 7 over x squared. And you divide this by x cubed, you get that. So that's essentially what step 2 looks like. And step 3, use the rules to get the limit. Now, what do I mean by the rules? I mean these guys. Right, so these two here. So let's see what we get. You would get 3 over infinity plus 1, 2, take away 7 over infinity squared, which just is infinity, plus 2 over infinity cubed, which is just infinity. And what I was doing here, I guess I could have stuck that in, is it's 7 over infinity. This guy here is essentially 7 over negative infinity, but you get zeros. So 3 over infinity is 0, add 1. 2, take away 7 over infinity is take away 0, add 2 over infinity is add 0, and the whole package comes out as a half. It's quite a clean technique, really. In fact, if you do the questions enough, can't you just look at the thing and tell what the answer is going to be before you even prove it, which is essentially what this is doing. So if I look at a question like this, I just say there's 1x cubed on the top, there's 2x cubed on the bottom, the answer is going to be a half. Now I can look at that pretty quickly and come up with the answer. Okay. Try another one then, just to show you some different versions of this. Let's do the limit as x tends to infinity of 7x squared plus 4x minus 1 over 2x squared minus 3x. Okay, what's the largest power of x in this expression here? Just
X
looking.
squared.
Okay, so I'm going to divide the top and bottom by x squared. That's good. So it now becomes the limit as x tends to infinity of 7, 4 over x, 1 over x squared, of 2, 3 over x. That's it. And then can't I just go 7, 4 infinities, minus 1 infinity, 2, 3 over infinities. 7 plus nothing, take away 0, 2 take away nothing, and the answer is 7 over 2. And what am I getting at this? This is the proof. We're not, I know WebAssign makes you sometimes take too big a shortcut, because in WebAssign, you're probably only going to type in 7 halves. But there's a lot involved going from here to here. And when you do your next test and you get a question like this, I don't want to know that the answer is 7 halves. What I'm really looking for is the proof, the process that you used to get to 7 halves. So try not to cut the corners too quickly. Try not to say, oh yeah, I've got a shortcut for that. I know the answer at 7 halves, move on. Because if you do that, you'll forget or you won't remember clearly how to do the whole process. So when you come up and you do a test question, you're going to tell me the right answer, that, but you're not going to be able to do this bit because you can't really remember what, because you never did it. I mean, you looked at me doing it, but you said, nah, it's too much work. You need to be good at these because that's what you're typically going to be asked. Mathematicians don't like magic. We don't like, oh, it's 7 halves, I found a shortcut, it works. I think it works most of the time, at least it works the ones I've done. That's kind of vague to them, they don't like that. So we tend to try and prove things when we do things. Now I'm going to, oops, I'll change back to my blue, I like my blue car. Now I'm going to show you an awkward version of that, because right now the ones that we've done have been very straightforward. I mean, can't you just go like that and say 7 halves? You know, if you're looking at a shortcut. Now, let's have a different power on the top than is on the bottom. Oops, that can't be that. Make that square. 2x squared minus 2x minus 2, right? Good. Okay, now we have a decision to make. On the top, it's x cubed, and on the bottom, it's x squared. What's the biggest power of x going on here?
It's got to be x cubed.
I don't care that only one of the fractions actually happen to have an x cubed in it. The rule doesn't change, so that's good news, right? If you've got different power of x on the top than you have on the bottom, it don't matter. The biggest power of x is still the guy that you're going to work with. Now it gets a little bit messier because of that. Let's see what I mean by a little bit messier. Well, that's 7. That's 3 over x squared. That's 1 over x cubed. This guy is 2 over x. This guy is 2 over x squared. And this guy is 2 over x cubed. Now I'm going to do what is typically called brute force, which is basically replace the x's with infinity. I get a 7. I can live with that. I get a 3 over infinity. I get a 1 over infinity. Is it okay that infinity squared is infinity and infinity cubed is infinity? Are you all comfortable with that? I don't need to write down infinity squared because it's still infinite. Now 2 over infinity. Take away 2 over infinity. Take away 2 over infinity. Now this becomes 7 take away 0 plus 0. And this becomes 0 take away 0 take away 0. Now do you see the problem? 7 over infinity would probably be called undefined. That's what you would call it in Math 141. Can we say now that it's not undefined? I know what it's going to be. It's going to be one of two things. It's either plus or negative infinity. Well, the way I've written it right now, you would say, well, that's 0 and that's positive and 0 is positive, so it's infinite. And you know, 0 doesn't have a sign. It's not positive and it's not negative. It's that one number in the middle that's neither. The result is that when you get a calculation like this, you know it's one of these two answers, but you do not know which yet. So we have to have a little side issue of how to figure out plus or minus. Agreed? How to figure out plus or minus.
Couldn't we just put the plus or minus sign?
Oh, but then you're saying it's one of two answers, and we'd like to know which one it is, because it is actually only one of those two choices. Any suggestions about how we decide if this answer is positive infinity or if it's going to be negative infinity?
There's no way you can graph it, is there?
Oh, graphing always works. So yes, that would be one solution, and that would be acceptable. Just plug it into WebAssign, and if it shot up the way, it was plus infinity, right? And if you've seen it shooting down the way, it's negative infinity. Suppose you, nothing wrong with that. I like it. It's a good answer. Any other ways you might be able to figure it out? You know, it's one or the other, right? You just need to figure out which.
You input a value, like a positive or negative value into.
Yeah, like 100 maybe, some big. And if the answer's 22 billion plus infinity, and if it's negative 22 billion negative infinity, none wrong with that. It's a good strategy. And, you know, it's a bit messy because there's, you know, a lot to do, but it works fine. None wrong with that. Any other suggestions? Both of those work totally fine. There's one more. Any ideas of how you could tell whether this thing here is going to be positive or negative?
I guess. Oh,
yeah. No, go for
I
it.
was just thinking the x squared divided by the X cubed is going to be negative X.
Oh, I see what you're thinking. Well, it's pretty close to what you said, but the conclusion is going to be different. Actually, I think I'll do that in a new piece of paper. Here is a way of figuring out when you get this kind of 7/0 situation, what the thing is going to look like. Funny looking X. Now, you don't physically write down what I'm doing. I'm doing this for visual benefits, right? You see those funny little Olympic College wave equals looking signs? You see those guys there? Do you know what that symbol means?
Approximation.
Yeah. So I'm going to say, and this is hopefully intuitive. Since we are talking about really, really big values of X, would you agree that 7x cubed is phenomenally bigger than all the other terms? You know, like a billion cubed is going to be bigger than a billion, right? That kind of thing. So this fella behaves like that guy. So far, so good. And doesn't that guy simplify down to that fella? Now, if X gets infinite, doesn't that become 7/2 of infinity? Do you see a plus infinity there? Right, it behaves like that, which is simplified that. If you plug in infinity in here, isn't that positive infinity? I don't like the looks I'm getting. Cynthia, I'm going to pick on you because you're one of the faces I can see right now. That doesn't look good.
No, it makes sense, but what happens if you choose like a negative infinity?
Let's do it. If you choose negative infinity, then that stuff, it still behaves. Oops, don't know why I did my 7 so ugly, right? It still behaves like that, right? Which means it's going to be the limit as x tends to negative infinity of 7/2 x. Well, isn't 7/2 negative infinity? Negative infinity. Right.
Either way, you're going to end up with 7/2 x, and you're just going to
Yeah.
multiply by infinity. Got you.
So
I feel-
how did we get from the long equation to 7x cubed and 2x squared?
Right. The argument was that when x is really big, 7x cubed take away 3x plus 1 behaves just like 7x cubed would, because 7x cubed would be phenomenally, it would swamp the rest of the terms, so you don't really need to worry about them. Right. The major contribution to the answer is only given by the 2x cubed.
So because they are the higher power powered terms, we just took them out of the equation.
Yeah, we
as
just
their own
ignored all
separate
the
thing.
smaller ones and said the higher powers are the ones that matter. Give you a simple example. Suppose I had 3x squared plus 50x. Do you know if x was, say, a billion? That would be 3 trillion plus 50 billion. In the big scheme of things, do you think 50 billion is going to do much damage to 3 trillion? You see, the 3 trillion is where most of the value of the answer comes from. It comes from the first term. So that's the kind of argument I'm making. And it doesn't even need to be a billion. Couldn't the number be a billion, trillion, trillion? Right, in which case it would be even more obvious that the first term, as a percentage of the other, takes over. So let's do another one of those guys then.
So would
Yes.
so which one would the answer be? The positive or is that just not matter?
The answer in the question that we had is plus infinity. If I did this version of the question, the answer would have been negative infinity.
Oh, got you. Okay,
There
thank
are
you.
two different questions there.
Oh,
I've
okay,
just
thank
changed
you.
where the limit went to.
Gotcha, that
Okay.
makes sense.
Right, let's try another one. Let's do a limit as x tends to infinity then of 10x to the 4 take away an x squared over 5x cubed plus x plus 1. Right, largest power of x in this case is x to the 4, agreed? Largest power of x is x to the 4. That gives us the limit as x tends to infinity of 10, take away 1 over x squared, 5 over x, plus 1 over x cubed, plus 1 over x to the 4. Now if I plug in infinities, what do we get? We get 10, take away 1 over infinity, 5 over infinity, plus 1 over infinity, plus 1 over infinity. So that gets me 10 take away 0, 5 over infinity is 0, 1 over infinity, 1 over infinity. We have that dreaded some number over 0 situation again, right? The first time it was 7 over 0, now it's 10 over 0. What this process has done has just got to the point where we know the answer is infinity, but we don't really know which one yet. Okay. If you look at this question here, isn't that the only part that matters, right? So this fella here, the limit as x tends to infinity of that stuff is approximately going to be the same as the limit tends to infinity of this guy, which becomes the limit as x tends to infinity of 2x. And if you plug in infinity there, yep, the answer again happens to be positive infinity. So it's like a two-stage. That guy tells you it's infinity, and this guy tells you what kind of infinity. One last one of this type. Let's do the limit as x tends to infinity of 7 minus 4x cubed over 2x plus 1. What am I going to divide top and bottom by in this question? What power of x?
X cubed.
X cubed. So it's going to be the limit as x tends to infinity of 7 over x cubed, take away 4, and 2 over x squared plus 1 over x cubed. And this fella is going to be 7 over infinity, take away 4, 2 over infinity plus 1 over infinity. And I get 0 take away 4 and 0 add 0. I get negative 4 over 0. Now that also means I'm going to get some kind of infinity, right? It might be plus infinity, it might be negative infinity. I'm pretty sure it's going to be negative in this case, but we should always check it. Won't this guy simplify down to a negative 4 over x cubed, squiggly lines, over a 2x? And that becomes the limit as x tends to infinity of negative 2 x squared. Okay, I'm running short of space here. If you plug in infinity in here, don't you get negative 2 times infinity? And isn't that negative infinity? You agree? What would the limit to this fella up here be if it was x tending to negative infinity? Because the math would be exactly the same. You still end up with a guy that looked like this. But the limit as x tends to negative infinity, doesn't it become negative infinity squared and then stick a negative 2 in front of that? So what kind of answer would you get for negative infinity?
Still negative?
Yeah. So do you see, don't get into the habit that, oh, x tends to infinity that gives you plus answers and x tends to negative infinity gives you negative answers. Can you see in this case, x tends to negative infinity also gives you a negative answer, right? So anything is possible, right? So you do have to do this little check thing here. You know, reduce it and see what you get. Where is it? Reduce it and see what you get. And that's how you kind of can be certain about that. And if you choose not to do this technique, can't you just plug it into WebAssign and look at it? Couldn't you pick a number like 100 and decide that way? And so it is possible to do it other ways. Let's show you. Oops. Let's show you another version of that situation. Okay, doesn't look that different from the ones we've been doing. The answer is going to be quite interesting. What do I divide top and bottom by in this case?
X cubed.
You get 5, take away 4 over. Have I just done that one, haven't I? Oh, shit. No, I can fix it. I'm doing another question just like the others. So forget that. You're going to get an answer when you're finished of infinity, so I don't care about that one. I want this one. Just a little change, but this little change is going to make a difference. Oh, can you just trust me that if you went through all the work here, the answer would be infinity, right? You can finish it off yourself. This is the question I should have gave you. Okay, highest power of x this time is now x to the 4. So we're now going to get the limit as x tends to infinity. 5 over x, 4 over x cubed, 2, 1 over x cubed, and 10 over x to the 4. Now when you do the brute force, 5 over infinity, 4 over infinity, 2, 1 over infinity, 10 over infinity. Look at what happens. 0, take away 0, 2, add 0, add 0. And that ends up being 0 over 2. Okay, what's 0 over 2 going to get you?
0.
0. So the good news is you don't have any extra work to do. When it's that situation, don't you just get zeros? 10 over 0 minus 40 over 0. Who cares? Right? Sorry. 0 over 10, 0 over minus 40, whatever it is. Don't matter. 0 over some number is going to be 0. So when that happens, now what's the difference? Well, if you look at my first question, which is the wrong one I wanted to do and the one I did, do you notice the only real difference is where the biggest power of x is? If the larger power of x is on the top, aren't you going to get some type of infinity? Plus or minus infinity. If the largest power of x is on the bottom, aren't you going to get 0? So when you look at a question like this, you could do it in WebAssign. You could just say, oops, 0. And you'd be right. And WebAssign wouldn't know any better. But you have to prove it to me, right? You know, there's a lot of work to it. So I'm just pushing that thing that make sure that you understand the process of proof, because what we're really should be asking you is prove to me that this answer is 0. Or plus infinity as it would be in the other case. Do you want to see another one like this, or is this second situation looks a little bit more obvious than the other one? That'd be good. Did you want to see another one? I see nods, so I'm assuming that means you're good. Okay. So let's move on to situation 2. Square roots. And the good news is that this is really just an adaptation of step 1, right? Most of what we do is exactly the same thing. Now you can imagine that something like that might be a bit scary because there's square roots and it's got fractions and it's got, oh God, who knows what else, right? It's not really as bad as it seems. We are going to divide the top and bottom by the biggest power of x. But you have to be aware that an x squared inside a square root is not really worth an x squared. What do you think the square root of x squared is really worth?
It's times 1/2, so it's just x.
Right. So the square root of x squared is really just like an x. The square root of x to the 4 is really an x squared, right? Its basic value is about that. Which means in this case, would you agree that you divide the top and bottom by the biggest power of x, right? So we're still using that trick, right? Dividing top and bottom, in this case by x. That's fine. Now it gets a little bit, just a little bit awkward. I'm going to do the easy ones first. Divide that by x, you get 5. Divide this guy by x, you get that. Divide this guy by x, you get 2. I like that. Oh, how are we going to divide this fella? This is the awkward bit. How are you going to divide him with x? Well, you don't divide him really by x, because this has got a square root and that doesn't. So what you do is you divide it by the square root of x squared. Isn't that the same thing as x? So what does that give me? It gives me a 1 plus a 5 over x squared. Does that make sense that if I wanted to divide this by x, I convert it into a version that plays well with square roots, right? So I convert it into a square root version, right? So x is square root of x squared. Now I can do the division. So this fella here becomes the square root of 1 plus 5 over x squared. That's the tricky part. If you're comfortable with that, the rest is going to come pretty smoothly. Are you comfortable with this square root, how we dealt with it? Okay. Now, brute force is coming up. Square root 1 plus 5 over infinity plus 2, that goes in the top. And 5 plus 1 over infinity goes in the bottom. square root of 1 plus 0, add 2, and on the bottom, 5 plus 0. Would you agree that the square root of 1 is 1, so 1 plus 2 gets you 3, and 5 plus nothing gets you 5, and there you go. Are we comfortable with that, guy? Suppose it was a test and I wanted to check that this limit was 3/5. Couldn't I just plug it into Desmos and see a horizontal asymptote at hopefully 3/5? Couldn't I pick a number like 1 billion and calculate it and get 0.599998, and that would say, yeah, that looks like 0.6, which is 3/5. I could check it that way too. Okay, let's do another one. How about the limit as x tends to infinity of the square root of 4x to the 4 plus x squared over x squared plus x minus 1. Okay, x squared definitely the biggest power of x in the bottom. That is easy, that's obvious. What is the power on the top here?
X squared.
Great. Isn't it really the square root of x to the 4, but the square root of x to the 4 is an x squared? That makes sense. Now, in this particular question, do you know I can save myself a little bit of work and pretend that it's already that? Isn't that x squared written in a form that's going to play well with the square root? Let's see what we get then. It's going to be the limit as x tends to infinity. 1 plus 1 over x minus 1 over x squared, 4 plus 1 over x squared. Are we good so far? Right. I'll do over here, I need more room. So brute force, square root 4 plus 1 over infinity, 1 plus 1 over infinity, take away that guy, square root of 4 plus 0 goes in the top, and a whole load of 1 plus zeros and minus zeros go in the bottom. But it's really the square root of 4 over 1, which is 2. Are we good?
Wait, did you divide the numerator and the denominator by different values? Like, is the top the square root of x to the 4th and the bottom x squared?
They're both the same. What is the square root of x squared equal to? Sorry, what's the square root of x to the 4 equal to?
X squared. Okay.
So it's the same thing, isn't it?
Yeah.
But the reason I wrote it like that is so it would play well with this fella, right? Algebraically, I can do the division when both things are the same format, right? So if one thing's a square root and I want to divide it, I better have the other thing as a square root so that they match.
I have a
Cool.
question about that.
Yes, Maggie.
All right, so are we saying that it's a positive square root because x is tending toward positive infinity?
No, we're saying it's a positive square root because that thing doesn't have a sign in it. If you wanted the square root question, that's a negative square root, guy. That's a positive square root, guy. It's positive because, technically speaking, if you don't write anything in front of something, isn't it positive? So it's positive for that reason. I could have done the same limit as x tends to negative infinity and it still would have been the same answer, right? It still would have been, you know, this working, and it still would have came out as 2. So this being plus or minus infinity does not directly affect this fellow. If this says plus, it's plus. If this says negative, it's negative. Does that help?
Yes, thank you.
Okay, let's do another square root with an answer that you might not like, but it can happen. There's one. Okay. What is the largest power of x here? And it's not x to the 4. Remember, x to the 4 really isn't x to the 4. It's really worth x squared. So what's the highest power of x in this fraction, or this expression?
X cubed.
X cubed. Now, I'm not going to put x cubed here. And I'm going to do that square root of x to the 6 to make it play well with the square root. It's still x cubed, right? But I'm writing it in a way that's going to allow me to deal with the square root better. So this is going to be the limit as x tends to infinity of 1 plus 1 over x squared and 7 over x cubed. And if you divide this guy by x to the 6, you get 1 over x squared, and the other term, you get 2 over x to the 6. Cool. Now I can do brute force. 1 over infinity, 2 over infinity. 1 plus 1 over infinity, take away 1 over infinity. Square root is 0 plus 0 on the top, and 1 plus 0, take away 0 on the bottom. And this guy is 0, and this guy is 1. What's the final answer?
Zero.
Correct. Right, we've got a few minutes left, so I want to just show you almost the same question. You see, the only thing I've done here is turn it upside down, right? Did the reciprocal. I'm still going to divide by x cubed on the top and by the square root of x to the 6 on the bottom. When I do that, I'm going to have almost identical working, just reversed. But when you do the brute force, you see the problem. What kind of answer are you going to get out of 1 over 0?
Either positive or negative infinity.
Right. So don't we have to figure out how to figure out which one it is? In a question with square roots, the surgery thing doesn't work as well. So I suggest that you just pick a big number like 100. And if the answer is positive, it's plus infinity. If it's negative infinity, it'll come out as negative infinity. This one happens to be plus infinity. So I would just do the numerical check. You could do the Desmos check as well, but I don't know. Yeah, you could. I'm not saying you couldn't. If you did the Desmos check, wouldn't this function, this whole thing, I don't know what it really looks like, but wouldn't it level off at 0 if it looked like that? And it would go if it was plus infinity, and it would go if it was negative infinity, right? You'd be able to tell just by looking at the graph what your answer would be. Okay, we're going to call that a day, everybody. Sorry for keeping you just a little bit longer. Well, it looks like my goal has changed. My goal is now going to be to finish this tomorrow. Say hi and bye-bye.